Hey guys, what is up? It's your pal Dave from notesandvolts.com here with a new-ish project. This is actually an older project. So a few years ago, I got a call from a very cool studio in California, and they were looking for a very custom device. They wanted this, a 4 fader box with nice long 100mm faders, and a way to program it so they can change the CC numbers without unplugging it or doing any programming. They could do it from a little interface. So I came up with an old school LED display and one button that lets you program all the faders. Now, I posted a video of this a couple years ago just showing the process and how I built this up. And a lot of people saw it and said, man, I really want one of these. So I thought, well, why don't I just give you the schematic and the code, and I'll kind of explain how it all works, and you can have a go at building one yourself. But before we get into that, I got to give a quick shout out to PCBWay for sponsoring this video. PCBWay is a one-stop solution for all your circuit board and manufacturing needs. They can do circuit boards, multi-layer boards, aluminum boards, 3D printing, CNC machining, injection molding, and assembly. They can do it all. PCBWay is very maker-friendly with lots of services for small creators like myself. So check out PCBWay today and they can make your dream project a reality. Click the link in the video description to let them know that Dave sent you, and you'll get yourself some free goodies. So thanks again to PCBWay. Now, first of all, I know there's going to be a lot of comments and questions, and I've done this a long time, so I can already predict what those questions will be. So let's just answer them all at once right now. Question number 1, can I add more faders, buttons, lights, OLED screens, lasers? And the answer is probably. The follow-up question will be, how do I do it? And that's the trick. I can't really tell you. The only way I can tell you how to do it is by doing it, and I really don't want to go back and reiterate this project a million times. So I'm putting the project out as is. If you like it, that's great, but feel free to take the code and modify it to whatever you want. The second question I'll get is, you used a Teensy LC processor for this project. Can I use an Arduino Leonardo Pro Micro Cincinnati, Ohio, or whatever newest Arduino there is? And the answer is yes, but you're gonna have to change a whole bunch of stuff. So it's kind of like the first question. You're gonna have to modify the code, and I don't really want to get into how to do that. So this is designed for the Teensy LC microcontroller. So the third question will be, do I have to use the exact faders you use? Can I use shorter ones? Can I use turn pots? Can I use whatever? And the answer is yes. You can use any type of potentiometer you want. Just try to keep it around 10K and linear taper. Whatever shape size you want should work just fine. The next question will be, can I replace those faders with rotary encoders? And the answer is no, because rotary encoders work totally different. They are digital devices. This is expecting analog potentiometers, so that would be a whole different project. All right, let's do a quick demo of how this device works. So you just plug a USB cable into the back. It's USB powered, so that's all you really need. Now, as I move the faders, you can see this MIDI monitor is showing what the unit is putting out. So the important columns to watch are this first one. This is the MIDI CC number. So right now we're on MIDI CC 1, and this is on 2, this is on 3, this is on 4. This column here will show you the fader position, or the data the unit is putting out, and it's also updated in the display. So as I move it, you can see I can go all the way up to 127 and then all the way back down to 0. And this last column here is the MIDI channel. So it's a global MIDI channel, so all the faders will be on that channel. Right now we're on channel 1. So you're probably going to want to set up some custom CC numbers for each fader. And everything on this unit is controlled by this one button. So I tried to keep it as simple as possible. So to actually see what CC the faders are on, if you just push the button, it will show you fader 1 is on 1, and then you go to fader 2, fader 3, fader 4, and then back to fader 1. To get out, just leave it alone for a few seconds and it will go back to normal, and then you can go about your normal mixing. But to change it, select the fader you want, so fader 1, and then hold the button down. Now it will start blinking. Just move the fader to whatever number you want. So let's go to, how about 20? And then release the button when you're there, and now this is programmed on 20. And leave it alone, it will go back to normal. And now you can see that this fader is in fact on CC number 20. Now if you want to do multiple faders, you can kind of do it without breaking out of edit mode. So just select the fader you want. So let's go to 2. Right now it's on 2. Hold it down and let's go to 21. Release it. Hit the button again. Now we're on fader 3 and hold it down. Let's go to 22 for this guy. Release it. So as soon as you release it, it's programmed. And let's finally go to fader 4 and let's go to 23 and release it. Now all our faders are programmed. Just leave it alone. It will exit out of edit mode. And now you can see we're on 20, 21, 22, 23. Now to change the MIDI channel, just hold the button down and you'll get to this mode. So it's saying right now we're on channel 1. Just move any fader. You can go up to channel 16. Let's set it to say channel 7. Once you're there, hit the button to save. And now you can see all of my faders are on channel 7. Okay, so let's talk about this project a little bit. Let me give you a little of the background and the history of this project, and then we'll look at the schematic and I'll show you how it all works. So one day I got an email from someone and they said, I work for this big studio. We have this thing, we need an updated version, can you help us? And they told me exactly what they wanted. So they had this 4 fader box that they really like to use, but the problem was that when they needed to change the CC values on the faders, they had to take the box out, hook it up to a computer, and send a program up to it to actually reprogram these faders. And they said that's not really cool, it takes a lot of time. So can you make something that we can change sitting at the desk? Now they also said we only need the top plate. So we have a carpenter who works for us who designs all our studio furniture, and he's going to make a custom box for it that's going to match everything else we have. So we only need the metal top plate and some kind of way to hold the cable. And then they actually sent me pictures of what he came up with, and it's amazing. So, you know, hats off to that person. So I designed the top plate, and I also designed this back plate that holds the USB cable and makes it easy for them to just drill a hole in the back of the enclosure and screw it in, and it makes it look real nice. I decided to go with the LED display because for one, I like the look of them. It's kind of old school. And the second, I thought, you know, in a dark studio, it's going to be easy to see. Plus, you know, with an LCD display, sometimes you get contrast issues depending on how you're looking at it, and maybe brightness issues. So, you know, the LED display is just going to show up and it's going to look really nice. Okay, so let's talk about the actual insides of this and what's going on with the actual hardware. So I actually found the prototype I made for this, and this is it. And you know, creation is sometimes a messy business, but this is the actual prototype when I was designing it that I was working on. And you can see the actual parts. So we've got the Teensy LC microcontroller, that's the brains and that's controlling everything. We've got this chip here, which is basically a level converter. So it takes 3.3 volt logic and boosts it up to 5 volt logic, because the next chip, which is a custom display driver, requires 5 volt logic. So this chip here, this is a Max 7219. It's a custom display driver, and it makes driving these displays very simple and elegant. All right, so you can see how you could build one up even on a breadboard, but let's take a look at the schematic and we'll see exactly what's going on. Okay, so here's the schematic. Let me go through it and kind of explain what's going on. So we'll start here. This is the actual USB jack where the cable would come in, and the USB cable provides us with 4 things. It provides us with 5 volt power, which is on this pin here. It provides us with ground, and it provides us with 2 data signals, a D plus and a D minus. Now you can see the teensy microcontroller here. So first thing, let's take a look at the power. So the 5 volt from our USB cable is being supplied to this V-in pin here. So these two would be connected. Like I said, the Teensy is a 3.3 volt device. It doesn't like 5 volts. So the Teensy will regulate that 5 volts down to 3.3 volts. It's going to make that 3.3 volts available on this pin here. Now here are the actual fader controls. You can see on one side I'm using 3.3 volts, so I'm taking it right from this pin and putting it on one side of the fader. The other side of the fader I am using ground, and that ground is connected to the Teensy ground, which is also connected to the USB cable ground. So all the grounds are connected together. And finally, the wiper of the fader goes to one of 4 analog inputs on the Teensy. So the only other input we need is this push button. This is a normally open momentary button, and it just goes to pin 12, and the other side goes to ground. Now the rest is all output and driving our display. So you can see these 3 pins here are actually driving our Max 7219 display driver chip. Now unfortunately, this chip runs on 5 volt logic, so it's expecting 5 volt signals. And like I said, our Teensy is a 3.3 volt device, so that can sometimes cause some problems. So what I'm using here is a 74AHCT125 chip, which basically just takes our 3 volt signals in and converts them up to 5 volt signals. That's all it does. Now on each chip I have a capacitor, this guy here. Now you notice we have 5 volts going into both these chips, and that's our 5 volts coming from our USB cable. So that is what's powering each chip. But what I always do when I'm using logic chips is I use a little capacitor. This is a 0.1 microfarad capacitor, and this is called a bypass capacitor. And you notice it's connected one side to the 5 volt VCC pin of our chips and the other side to ground. And what this does is it just acts as a little reservoir. So if there's any power fluctuations in our circuit, it's just going to smooth them out. And that can sometimes save you a lot of headaches later on. So just as a matter of course, whenever I'm using a logic chip, I will add a small bypass capacitor. And when you're laying your circuit out, you want to physically put that capacitor as close as you can to the actual pin on the chip. Now, the Max chip is fantastic. Like I said, I'm a big fan of these chips. So you can see, here's our display. This is the actual model number, the YY5631AH. That's the actual model number I used. But you can use any 3-segment display. This is called a common cathode display. So you can see these displays basically have a pin for each segment, and then individual pins for each LED in the segment. So the way this chip works is it will enable one segment and then send the correct data to light up the correct lights in the segment. And then it will switch to the next segment, and then it will do the same there, and it'll switch to the next segment and do the same there. Now if you notice, you can actually put more digits if you want to. You could actually put 8 digits on this one chip, but I only needed 3, so I'm just not connecting the rest of them. The only other component I have really is this 33K resistor on the I-set pin, and one side's connected to our 5 volts, the other side's connected to the pin, and this is the current limiting resistor for the display. So this will determine how bright this display is, and by a little trial and error I found 33K to be the perfect brightness for my needs. One little thing to point out, anything with an X on it means don't connect it to anything, just leave it alone. So you can wire up the circuit on a breadboard or make a custom board for it or whatever you want. The only thing you got to really think about is how you're going to get the USB cable into your Teensy. So technically you could use something like this. This is a USB micro to panel mount USB type B, and I like using these because they're nice and big and solid. But you could just plug this in here and route this to the back of your enclosure and screw it in, and there you go, power and data to your Teensy. The other way you could do it is to take a cable like this, which breaks out the signals into individual wires, and you could run it to like a header on a circuit board or something like that. And that's actually what I did in this because it's a little more solid in my opinion. But what you have to do is get the data, the D plus and D minus pins from this into your Teensy, and unfortunately there's no way to break it out. There's no pin that actually breaks out that data plus and data minus. But if you look on the bottom, there are 2 pads here. And you can actually solder wires to those pads and then bring them out to your circuit board, and that way you can connect the D plus and D minus data pins to your Teensy. So that's the other way to go. So I needed to come up with the top plate. Now, you know, making a top plate like this is beyond my capabilities. It would be a nightmare to machine this stuff. So this is actually stainless steel. So yeah, there's no way I could cut this out myself. But luckily, I have a friend who hangs out on my Twitch streams, and he owns a shop that actually does this. They have a giant laser that can laser cut anything you want. So he was nice enough to make these for me, and the back plate as well, and they came out perfect. So you know, special thanks to that person, because that was a real lifesaver in this case. Now, before you program the Teensy, you're going to need to obviously get the code, and the place to get it will be my GitHub page. So I'll put some links below, but eventually you will wind up on my GitHub page. You want to check out the repositories and go to the FADR-4 repository. So here's the code. I've included the schematic and a user guide, and here's the actual program. But to get it all in one shot, just go to Releases, select the latest release, and then select the file type you want. Probably zip is the most common, but you can also get tar if you're fancy, and click the link to download it. Let's talk a bit about the software and how to get it onto your Teensy. So if you don't want to mess with the code, you don't want to look at it, you don't want to touch it, you just want to build this thing and get it on your Teensy as easily as possible, let me show you how to do it. So get a micro USB cable and plug in your Teensy. Next, go to your favorite search engine and do a search for Thai Tools. And you'll find this Coral Mix Thai Tools GitHub page. Go to Releases and you'll find the most recent release, and just pick whatever version you need for your operating system. So OS X for Mac, Windows 32 if you have an older Windows computer, or Windows 64 if you have a newer Windows computer, and just download whatever file you need. Unzip it and you'll get a few little things. Open up the thaiuploader.exe. You will get this little window that will pop up. So first of all, you should see your Teensy listed in this menu. So my Teensy is actually programmed with something else, so it's showing up with this weird name, but you should just see your Teensy show up in this window. Make sure it's selected. Now click the upload button. Now you'll go to the FADR-4 code, and go into the folders, and you should find this FADR-4.hex. So this is a pre-compiled file. So just select that, open it up, and done. And just like that, the Teensy is programmed. And if you check on your operating system, you should see this as a new USB device called FADR-4. And if you see that, you are good to go. Now, if you want to go into the code and play with it and change things, you're going to have to do it the little more complicated way. So what you'll need is the Arduino software. Before you download and install that, you're going to want to check the version number. So you're going to need an extra piece of software to actually program the Teensy. So to get the Teensy software, you're going to need to go to pjrc.com and look up Teensy-Duino. Now this is a little add-on program that's going to enhance your Arduino software and let it work with the Teensy microcontroller. So first of all, check which versions of the Arduino software this will work with. It may not be the latest one. So this right now works with 1.8.5 to 1.8.19. So if there's a newer version like a 2.0 or something, it might not work yet. So download one of these versions. When you install the software, it's going to ask you to choose what libraries you want to install along with it. Just choose them all and install them. They don't take up much room, and you'll be glad you have them later. Once you have your Arduino software and the Teensy software installed, open up the FADR-4.eno file, and you should get two tabs on the top here. So one will be called name.c, the other will be called FADR-4. So here are the settings you need. So the board is going to be Teensy LC, the USB type will be MIDI, and the CPU speed will be 48 megahertz. Now to set all that stuff, you go to the Tools library and you set the board type here. Now if you installed the Teensy-Duino correctly, you'll get this little Teensy-Duino section, and you can install select the Teensy LC. USB type will be MIDI, and CPU speed 48 megahertz. And that's all you need. And you should see your Teensy show up as a port. Make sure you select it. There it is, the Teensy LC. Once that is all good to go, click the upload button. And there you can see the Teensy loader popped up, and it basically sent the code to my Teensy board. This code requires a couple of libraries, EEPROM.h and LED control. Now when you install the Teensy-Duino software and selected all the libraries, these should have been installed by default, so you should be good to go. So what do these libraries do? Well, the LED control library controls the MAX 7219 LED driver chip that we're using to run our display. The EEPROM.h library is actually the library that allows us to store permanent values in the Teensy's EEPROM. Now, this acronym stands for Electrically Erasable Programmable Read-Only Memory. So it's a type of memory that you can program and erase, but it will store information even if you power off the device. So that means when we program our faders and I unplug the device for the day, I'm not going to lose that data. As soon as I plug it in again, it's all going to be available. So a couple of little parameters. You probably don't want to mess with too much unless you know what you're doing, but LED level is something you can change. Basically that sets the brightness of the LED. I think it goes up to 15 at max. I found 2 is more than bright enough. The edit button is basically the pin that the edit button is connected to. If you want to change it, you could, but I don't see any reason to. So to do this project, all you have to do is get the code onto your Teensy using one of these two methods. So there you go, guys, the FADR-4 project. I hope you enjoyed it. If you build your own, let me know. I'd love to see what you come up with. So once again, thank you to PCBWay for sponsoring this video, and I'd like to give a huge shout out to my patrons on Patreon. Thanks again, guys, for helping me out, and let's enjoy your names.